A very good afternoon to one and all who are connected with us. I'm happy to welcome you all to the 92nd CME event organized by the Continuous Medical Education Committee, Faculty of Medicine, Bioscience and Nursing, MAHSA University. Today's speaker is Dr. Madhu Katyayani. She's Associate Professor in the Department of Pharmacology, Faculty of Medicine, Bioscience and Nursing, MAHSA University. Prof. Madhu has her bachelor's in pharmacy and master's in pharmacy and her PhD, all from Andhra University, India. And Prof. Madhu has 22 years of academic teaching experience. Her research interests mainly focus on natural products, for which she has got several FRGS grants. Her current project that she is working on is on the molecular mechanisms involved in wound healing properties of Melastoma malabathricum. And I think she's going to share her research findings of this project today with us in our CME. And she does have several publications through the works that she has done on her FRGS grants, mainly focusing on natural products. So I think I'll not take much time. I would like to invite Prof. Madhu to deliver her talk today. Over to you, Prof. Madhu.
Good afternoon, Prof. Deepa. Good afternoon, everyone. I am Madhu Katyayani from Department of Pharmacology, Faculty of Medicine, Bioscience and Nursing of MAHSA University. Today, I am going to give a talk on my research topic, wound healing activity of Melastoma malabathricum leaves. So, moving on, what are the contents that I'll be discussing? I'll be giving you the information is about the introduction, about the topic, literature review, research question, hypothesis, objectives, research methodology, results and discussion, and conclusion. So, regarding this topic, the introduction about the topic. So, the wound care cost is increasing continuously over the years. According to the current data reported, the global yearly cost of wound care in 2014 was about 2.8 billions, and that it is 3.5 billions by 2021. And according to the market research projection, the wound care closure products in the market will exceed to 15 billions by 2022 is the expected one. And the wound care products in the market would exceed to 22 billions by 2024. So these interesting figures are the fundamental driving force for many of the academicians or the researchers to develop better methods and technologies for healing wounds and regardless of their underlying causes or something. Then regarding the literature review, moving on to the literature review, the Melastoma malabathricum species belongs to the family Melastomaceae. The plants belong to the family, those plants which are belonging to this family Melastomaceae are found in tropical, subtropical regions in the world, including this Malaysia, Indonesia, Cambodia, and many other countries. Around 12 species are found in Malaysia, and out of them, Melastoma malabathricum is most widely used plant in traditional medicine, as it has various traditional uses, mainly for treating wound healing, dysentery, diarrhea, ulcer, like that, to name them few. So, thus, the main focus in this study is to investigate the molecular mechanisms in the wound healing activity of the extract, and the 3T3 cells, that is primary murine fibroblast cells, were used to study to assess this wound healing properties of Melastoma malabathricum. So moving on to the research objectives. So what is the research objective is that the research question is how Melastoma malabathricum leaves do exhibit wound healing properties. That means, I mean to say, the molecular mechanism involved in wound healing properties of Melastoma malabathricum species, that Melastoma malabathricum leaves. So, research objective is to determine the molecular mechanism involved in wound healing properties of Melastoma malabathricum leaves. Moving on to the hypothesis. The null hypothesis is the wound healing activity of Melastoma malabathricum leaves is not mediated via the expression of genes associated with hemostasis, inflammation, neovascularization, granulation, reepithelialization, remodeling. Usually, these are the 5 mechanisms of wound healing, or hemostasis, or inflammation, neovascularization, granulation, reepithelialization, or remodeling. So, the alternate hypothesis is the opposite of the null hypothesis, which is the wound healing activity of Melastoma malabathricum leaves is mediated via the expression of genes associated with hemostasis, inflammation, neovascularization, granulation, reepithelialization, and remodeling. So, moving on to the materials and methodology. So, this is my overall methodology adopted in this study. Firstly, the leaves of Melastoma malabathricum were bought in Sungai market, and the leaves were collected and extracted with methanol water using Soxhall's apparatus. The bioactive constituents in the extract are profiled using UPLC, and primary murine fibroblasts, that is NIH 3 cells, were utilized to test the wound healing capabilities. And the wound healing capabilities means the wound closure and migration rates were recorded at different time intervals. First, the cytotoxic study of the extract was found using MTTSA, and then we tried to find out which dose of the extract is safe for the cells, and then we have further continued with the wound healing activity. The wound healing activity is found by scratch assay. So then the relative expression of the genes with the plant extract is quantified by using this qPCR, and the experimental results were statistically analyzed via one-wave ANOVA using Graph Prism 9 software. So regarding this results and discussion and extraction of LCMS extract, this is regarding the extraction. 250 grams of the leaves were dried in a hot air oven at a temperature not more than 50 degrees centigrade, and the dried leaves were powdered in a blender and defatted with hexane. Then these leaves were extracted with methanol water 1:1 in Soxhlet extractor. The extract was concentrated to a small volume by using this rotary film evaporator, and the concentrated extract was dried in a freeze dryer. The percentage yield that was obtained was 32 weight by weight. That is the thing. And then moving on. Then this extract was subjected to this LCMS for the identification of the chemical constituents in the methanol extract. First, the extract was dissolved in ultra pure water and then sonicated, centrifuged. The supernatant solution was injected to the LCMSMS, and UHPLC machine, that is the ultra pressure high performance liquid chromatography, was used in this study. The company to which the study was done is UHPLC is AccuCore, and the column is 2.1 mm width and 100 mm length, and the pore size is 1.5 micrometers, and the elution was carried at 30 degrees centigrade. The mobile phase for this liquid chromatographic analysis consists of two solutions. The first solution is 10 micromolar ammonium formate and 0.1% formic acid in water at a pH of 3.1, and the second the second solution is the 10 micromolar millimolar ammonium formate and 0.1% formic acid in ethanol, and injection volume. So this is the second solution that is being used, and the injection volume is 5 microliters, and gradient elution was used for the separation of the compound. The extract was ionized using electron spray ionization, and the spectrum was recorded in electron spray ionization inlet tandem micro mass spectrometer. It is being recorded in. So that is a thing. And then regarding the chemical profiling, so the constituents. So this is auronamide. It is identified by comparing the mass and comparing its mass and mass fragmentation. And this slide shows HPLC profile of this peak, and it was eluted at a retention time of 6.3 to 6.4 minutes, and that molecular weight is 506.60. You can see it. Then another compound that is being isolated is betulin, which is eluted at 5.5 to 5.6 minutes, and whose molecular weight is 442.73. Then betulinic acid, which is this compound is betulinic acid, and it was eluted at the retention time of around 2 minutes, and whose molecular weight is 456.71. And all these compounds are characterized using M by Z value. Then catechin. So this is catechin, which is eluted at 4.9 minutes, and whose molecular weight is 290.08. And then geranin. This is geranin, and it was eluted at 4.9 minutes, and whose molecular weight is 952.65. This is very heavy molecule, big molecule with a chemical structure formula of C41H28O27. Then the next compound is camphorol. So it was eluted at around 5.1 minutes, and molecular weight is 286.24 with a molecular formula of C15H10O6. Then naringenin. So here also naringenin. This is the next compound which is being eluted. Then patrascabratin, which is another substance which has molecular weight of 444.53, and that quercetin eluted around 7.8, and that the molecular weight is 302.24. Then rutin, So routine, the molecular weight is the chemical formula is C27H3018, and that the molecular weight is 610.52. So these are the compounds. This is a summary of the phenolic compounds that are extracted from the extract. The other compounds are also present in addition to these things. So, in addition to these listed compounds, many other compounds belonging to different categories like sterols or the polysaccharides, amines, waxes are also present, and that the one which is shown in the table is mainly the bioactive compounds. So, we've concentrated mainly upon the bioactive compounds. Moving on to the cytotoxic studies. The next one is cytotoxicity of the Melastoma malabathricum leaves. So, the main purpose of this study is to determine the dose range of the extract that is safe to use, safe for these 3T3 cells. So, 3T3 cells were purchased from ATCC, and the extract was dissolved in molecular biology grade DMSO solution. The solutions were diluted using twofold dilution method with RMPI medium to obtain the required concentration of the test solution. The concentration used in the test study is in the range of 2.5 to 160 micrograms per ml. It was made sure that the concentration of DMSO is not more than 0.05% because there are certain reports that high concentration of DMSO is toxic to cells. So we have used only less than 0.05%. So the blank wells contain cells and medium, and the control wells contain cells, medium, and DMS of 0.05%, and the treatment wells contain cells, medium, and test solutions. So, moving on. Here, the cells were allowed to grow for 24 hours, followed by treatment with test solutions for 24 hours, and then the MTT solution was added, incubated for 4 hours to produce the color. The intensity was measured using Tecon plate reader at 570 nanometers with a reference wavelength of 630 nanometers. The percent viability was calculated using the formula which is shown here, and GraphPad Prism 9 was used to perform the statistical analysis, and so this is the standard procedure cited in many of the research articles. So the statistical significance of cell viability was determined by one way, followed by this Crus-Wallis test. We were following it. So this is a standard procedure that is there. Then moving on, these are the results of the cytotoxic studies of Melastoma malabathricum leaves. So these studies show that the cell viability was not affected until the concentration of 80 micrograms per ml, whereas 160 micrograms per ml, the extract inhibited the cell growth. So until 80 micrograms, it is safe, is what we understood. So you can see that significance is only 160. Significant cells were affected only at 160 micrograms. Then summary. So with this we can conclude that the test extract is safe until 80 micrograms. It means that the extract is safe from 2.5 to 80 micrograms per ml. Therefore, for the subsequent wound healing experiments, the maximum concentration that was used is 80 micrograms, and the test range was ranging from 2.5 to 80 micrograms per ml we were using. So this is about the wound healing studies. So wound healing studies were carried out using this 3T3 cells. The cells were seeded at 2 into 10 to the power 6 cells per well in 6 well plates, and they were allowed to grow to form a uniform monolayer. When the cells form a uniform layer, scratch was made using this sterile micropipette. So the cells were treated with at different concentrations. The concentrations that we selected were 10, 20, 40 micrograms per ml. So the scratch was observed at various time intervals, that is at 0 hours, 12 hours, 16 hours, 20 hours, 24, 36 hours, 48 hours, using this Nikon Eclipse TI-U inverted microscope. So that is the thing. So the two wound healing parameters that we have found is the wound closure and migration, which was calculated by using the formula stated here. Then, so regarding the effect of the extract on the wound closure. So this graph shows the effect of the extract on wound closure. The effect was dose dependent and time dependent, you can see. And at 40 micrograms per ml dose, the wound was completely closed at 48 hours. And the cells were treated with this 10 micrograms, 20 micrograms, as well as 40 micrograms per ml. And at different intervals, 0 to 12, 16, 20, 24, 36, 48 hours, all the way we were finding out the results. This is the graph. So this figure shows the effect of the extract on the wound migration rate. The rate was dose dependent, but it is not time dependent. Okay. So here wound closure and migration rates. So significant effect on wound closure was started to be seen at 24 hours, starting from 24 hours, and very much it was closed by 48 hours. So this is regarding this. You can see the negative control and the leaves extract. So the extract showed dose dependent and time dependent effect on wound closures. And significant wound closure was observed around 12 hours after treatment. And the wound was almost completely, around 90% it is closed by 24 hours. And the wound was completely closed, like almost 90% by 24 hours and almost 100% by 48 hours. Whereas the control wells, the wounds are not completely closed. Then we moved on to the gene expression studies that we've conducted. So first, the RNA was isolated from the cells using the kit, the RNA Easy Mini Kit. So we followed the manufacturer's instructions, and that the quality and quantity was determined by measuring the absorbance of RNA solutions at 230 nanometers, 260 nanometers, and 280 nanometers. And that the absorbance ratios 260 over 280 and 260 over 230 were calculated. And that the expected values for 260 over 280 is in the range of 1.8 to 2.0, whereas the absorbance ratio for 260 over 230 nanometers is in the range of 2.0 to 2.2. So these are the expected one. So Moving on. So these are the values obtained from control samples and test samples. These results show that all the RNA are of good quality because the values are 1.8 to 2.0 for 260 over 280 nanometers, and the values are in the range of 2.0 to 2.2 for 260 over 230. So nanometer ratio. So, and you can see all these values. Then this is the concentration of the RNA in the sample. These are only the representative values. So the primers for the quantification of this RNA was designed using this online tool IDT Primer Quest and Oligo Analyzer online tool, which is available from a company website, Integrated DNA Technologies USA. These are the following standard parameters that are used to identify the primers and design the primers, which is widely available, widely reported in the literature as well. So these are the details of the forward primers and reverse primers. In total, we have tested the expression of 17 genes. So these are the genes: CCL2, VCAM1, ICAM1, collagen1, CXCL8, CXCL10, CXCL11, EGFR, MCSF, TIMP1, TIMP2, PAH, IL6, MMP. These are all the genes which are associated with wound healing. So these are the things. So we have used GADPH as the reference gene to determine the relative expression of the genes. So these are the product lines. So the quantification was performed by using well-known technique, qPCR technique, and this qPCR was performed by using this Thunderbird SYBR qPCR mix, and these are quantified using thermal cyclers B1000 touch from Biorad. The amplification of the genes was detected using CFX96TM real-time qPCR system. These are the qPCR conditions. These are very standard conditions which are widely reported in the literature as well. So initially, the RNA was denatured at around 90 degrees centigrade. The denaturation was carried out for 40 to 60 times, and each time the temperature was maintained at 94 degrees centigrade. Depending upon the gene, the time maintained at 30 seconds, 10 to 30 seconds. So later, it is followed by annealing, extension, fluorescence reading at a temperature of 3 to 8 degrees. So that is the thing. Then so qPCR, the GADPH gene was used as a reference gene, and the relative expression of the genes was calculated by this method. And then qPCR studies of chemokines, that is, this slide shows the effect of the extract on the expression of chemokines. So you can see is what are you can see from here that the extract has upregulated this CXCL expression by 1.75, and if you see CXCL10 by 3.16, CXCL11 by 2.87. So these are the things. And then here, moving on, Here in the qPCR studies for the adhesion molecules, you can see from here the extract has upregulated VCAM1, VCAM1 and ICAM1. So 4.22, it got upregulated, and 6.44. And then in the case of qPCR studies on growth factors and interleukins, you can see from here the extract has upregulated this VEGF alpha as well as interleukins. So these are the these you can see what are being upregulated. So qPCR studies on metallopeptidases. You can see that there are TMP1 as well as TMP1 is upregulated 1.53, and you can see TMP2 also being upregulated, and that so these are the things. And then so here this is the qPCR studies on miscellaneous factors. So what are the things are which got upregulated is PAI1, and collagen 1 is also upregulated. So you can see all these things. So in conclusion, the conclusion from my study is Melastoma malabathricum leaves showed potent wound healing activity at 40 micrograms per ml, and the wound closure was almost closed, like around 90%, as I showed you before, by 24 hours, by 24 hours, and that this is mediated by the upregulation of CCL2 as well as CXCL10, CXCL11, VCAM1, ICAM1, collagen PA1, as well as TIMP1, TIMP2, as well as TIMP1, but VEGF alpha also got upregulated. The one which got downregulated is TIMP2, MMP, EGFR, as well as MCSF, as well as ERK1 downregulated, and selectin got also downregulated. So so this is regarding my study. So thank you very much for your attention. Thanks. So regarding this project, this project is supported financially by FRGS grant, and it was awarded to MAHSA University, and I am the principal investigator. The work was mainly carried out by Mr. Lau Zhensheng, MSc student who was enrolled in IMU, and work was closely supervised by Prof. Dr. Mallikarjuna Rao, Dr. Kavita, Ms. Kitke, Mr. Zhang Shiming, and Bhuvaneshwari. The other collaborators with the co-investigators are Prof. Sekaran and Prof. Chin also involved in this project. Thank you very much for your attention.
Thank you, Prof. Madhu, for sharing your research outcome on Melastoma malabathicum. I think I would like to request the participants to post your questions. If there's any questions, please do post it in the comment box. Okay, so far we don't have questions yet. So, Dr. Madhu, the whole research shows. I mean, you've used the 3T3 cell lines, right? For
Yes, yes, yes. We
so
used
that is the. Hmm.
3T3 cell lines for this work, Dr. Deepa.
Okay. The extract you were talking about is like methanol extract. So you didn't try any other extracts. No, aqueous extract studies were not done, is it?
We have mainly methanol water extract we were doing, but not the
Mm,
lipid soluble like hexane extract. Usually doesn't
mm,
have the active constituents. The bioactive constituents will not be usually present, so we have discarded that one,
mm,
and rather we have gone for only methanol water extract,
mm.
so that we can get majority of the bioactive constituents with that.
Okay, somebody, Katija, yes. Okay, not questions. Anything, any other experience that you want to share, Prof. Madhu?
I'm really thankful to MAHSA University for completing almost completing it is almost at the we are about to complete it. So they have totally helped us. Even though the grant has come, luckily the grant came from FRGS grant, and that MAHSA University has helped me to complete this. I'm very thankful for which.
Okay.
Mm. So
For the molecular mechanism, right? Like for molecular mechanism of the wound healing property. I mean, are you aiming at any animal model studies and all that, or?
this is more best is what we understood, because animal models we cannot be, because of the what animal protection that is there at the moment. This can clearly in our fundamental studies we can clearly make out which one is the one which can upregulate or downregulate through the laboratory studies, so that we can further uh, process it, is what we felt.
Okay. So I think that's all. There are no more questions. So thank you so much again for your time for presenting in the CME event today, Prof. Madhu.
Thank you
Thanks a
so much,
lot.
Dr. Thank you so much, Dr. Deepa, for giving me an opportunity to give this talk.
Okay, okay. Thank you. Thank you so much. So thank you all. With that, we come to an end of today's CME event, and we will have our next event on the 1st of July. So hope to meet you all then. Thank you all of you again.